Okay, let's start tutorial 3. This is chapter 3 in the manual. It's building molecules in 3D. So we will work with the 3D building tools in Spartan. And just a reminder where this chapter is located, where this tutorial is located, the activities menu, tutorials, and this will open essentially a little HTML dialog. Let me zoom in a bit. You can move between a set of computational topics and the tutorials, and we're down here in the third tutorial, building organic molecules in 3D. Okay, I'm going to move this off screen in just a second, but before I do, I just want to draw your attention to what the model kit will look like, at least the organic palette. And I'm just going to make this PDF a little bit larger and zoom in just to point out some items. Okay, so we'll open this in just a second, but the model kit, the 3D building environment, has a set of tabs at the top, and we'll be focused on the organic tab in the upper left. At the top of the screen, there's a view of whatever is selected, and immediately beneath that, there's a selection bar. Okay, this is what has focus. So there are a set of atomic fragments, there are a set of groups, there's a set of rings. The More menu is actually a shortcut to the File menu, but we have prepared additional group and ring menu lists, and you can make your own custom lists if you want. There's access to the clipboard, and then you can build via Smile or more commonly Inchy import. And at the very bottom of the at least the organic and inorganic tabs, you'll have the build menus, which sort of the build menu icons, which will include delete and make bond and break bond and minimize. Okay, so those should be available. Okay, so this is just a little preview of what this looks like, and now we'll go ahead and get started. I'll move this off to the side. We don't need to look at it anymore. I'll go ahead and walk everyone through the remaining parts of building. And what we'll do in 3D mode now is go to the File menu, New, Build, or just the New Build icon in the upper left corner, and we're going to build acrylonitrile. Okay, let me mention two things before we get started. I have the model kit popped out into the interface just for display purposes, and the standard display, if you click at the top of the model kit, it will return it to it's permanently docked on the right hand side of the interface. This is typically where you would find it. So I'm going to leave it over here on the right hand side. The second comment to make is just a reminder, and I'm going to close the building session just for a moment. There are just 3 ways to sort of begin working with molecules in Spartan. You can either do that via the New Build in the upper left, also the initial entry under the File menu, New Build, or New Sketch to the right of that, which is a 2D building environment, which we'll look at in the next tutorial, also under the File menu, New Sketch, or the Open, and that essentially accesses the File menu and assumes a pre-existing file exists, either something built in Spartan or some other program or in some other format that we can read. And we can read essentially almost all file formats. If you find a format we can't read, please point it out and we'll work on that. Okay, so we're going to spend time again under the File menu, New Build, or building in 3D. So with the model kit open on the right hand side, the organic model kit, I'll just point out the sp3 carbon is selected by default in the upper left. We're going to build acrylonitrile. Let me just remind people what that looks like. Go back to the tutorial. Okay, acrylonitrile. So we have an sp2 connection here, an sp2 connection to another sp2. So this will build the ethylene group, and then we just attach at one of the open spots on the carbons a cyano functionality group. Okay, so a cyano group. And I'll show you how to do that in a couple of ways. Okay, so firstly, let's go ahead and insert an sp2. Immediately under the tetrahedral carbon selected, the sp3 carbon is an sp2 option. So let's select that, and you see that the sort of display table or the display panel at the top reflects the sp2 carbon. The initial building entry is a double click, so just double click on screen. And I'll zoom in so we can see this a little bit better using the center mouse wheel to zoom in and out. I'm zooming in. I'm going to rotate around with the left mouse. Okay, so sp2 carbon. Okay, so we have 2 single attachment points and a double attachment point. Let me go back to the model kit and just point out that sp2 is still selected, and I'll complete this and build ethylene by attaching another sp2 carbon. And in the lower right corner of the interface, you can see the name ethylene. This just means that Spartan recognizes the structure as existing in the Spectrum Properties database. Okay, now we just need to add a cyano functionality group, and we can do that in a few different ways. Each of these attachment points are equal, so it doesn't matter which one we choose. I'm going to use the one here in the upper right. We can either via atomic fragment complete this, and we can do this by choosing immediately under sp2 carbon is sp. So sp carbon, I can click here and attach at a single attachment point and leave a triple valent attachment point open and complete that with an sp nitrogen to the right of the sp carbon and build acrylonitrile this way. Or let me demonstrate use of the delete functionality. At the top of the toolbar, you'll see just to the left of the minimize, there's kind of an eraser looking icon. That's delete. So we can delete those two. The other way to have done that would have been from the build menu, delete, and delete is also an icon at the bottom of the model kit as well. Okay, so I've deleted the 2 atoms that I just previously attached, and let me just go to the groups menu. So under the organic model kit, and go to groups, and cyano is selected. There are a number of groups available. I think the default is alkenyl, but let's go to cyano, and then just a single click to attach. Okay, and then this is acrylonitrile. We can sort of see that named in the lower right corner as well. Just to remind everyone, once we go to the view menu, which is accessed by clicking on the glasses icon, I call these the sort of Harry Potter glasses, or view under the build menu, those yellow open valences will fill automatically with hydrogens. Okay, so this is acrylonitrile. Let's just remind everyone of the mouse operations. So under view mode, we can use the right mouse to translate either right, left, or up, down. Use the left mouse button to press to rotate around the center axis. And then you can use the center mouse wheel to zoom in and out. Okay, so acrylonitrile. Next we'll build cyclohexanone. Let me go ahead and close the existing file. And I'm not going to save it, and we'll start a new build, and we'll build cyclohexanone. Let me also just remind everyone what that looks like. So cyclohexanone. So we'll start out with a cyclohexane ring, and I can introduce the rings menu. Okay, so from the organic builder, let's move to rings. So down sort of the bottom part off to the right-hand side, rings. Cyclohexane is selected. I think benzene might be the default, but you can grab cyclohexane from the list of rings, and then again the initial insert operation is a double click. And then what we'll do from here is we'll substitute one of the sp3 carbons, one of the tetrahedral carbons, with an sp2 carbon, and you can do that from the organic builder as well. So the top carbon is sp3, just move immediately underneath that to sp2, select that, and then just double click. And I chose the carbon over here to the upper right. Okay, and then to complete cyclohexanone, just move back to the organic builder and then choose an sp2 oxygen. Okay, if you choose an sp oxygen and try and double click, the organic builder won't let you do that, so you need to get sp2 and then make the attachment. Okay, and you can see down here in the upper, or rather the lower right-hand corner, Spartan has identified the build as cyclohexanone just to sort of confirm. And if you go to the view mode, again, Spartan will fill up all of the open valences with hydrogens. Okay, cyclohexanone. Okay, so if you've ever run into the solvent cyclohexanone, this is how you build it in Spartan. Okay, let's move on to something slightly more complicated. Still an organic molecule, but this has a little bit of stereochemistry. So this is limonene, which is maybe a flavonoid. It's a very simple natural product in citrus fruit. Okay, so let's go ahead and close this file, and we'll go to the file menu and do new build, or click on the new build icon in the upper left. We'll go back to the model kit, and we'll go to the rings menu, and we'll choose cyclohexane. If that isn't already selected, choose cyclohexane. Double click to insert, and let's zoom in a little bit. Okay, and this is sort of where we'll introduce the stereochemistry. Let me just point out there's sort of axial and equatorial. So the axial are sticking up and down, and the equatorial are sticking out. So if I say axial, I'm referring to the up, down, equatorial to out. So on an equatorial carbon, what we're going to do is add the functional group alkenyl, so basically an ethylene, and we'll add this to an equatorial attachment point. And we built vinyl cyclohexane. You can see that in the lower right corner. And then what we'll do, let's say this is at the 4 position. We'll call this the 1 position. Between 1 and 2, we're going to make a double bond, and we're going to do that at the axial attachment point, so at the top and at the bottom. So we're going to make a double bond. We can do that from the build menu, make bond, and it's also an icon that's permanently displayed at the bottom of the organic and inorganic builders, so it's down here as well, make bond. Okay, so in the make bond mode, we'll go ahead and touch the axial open attachment points. And then I'm just going to go ahead and click the minimize icon, which is always available at the top of the toolbar, and is also in the build menu at the lower right corner, just to clean things up a little bit. Okay, and also let me go ahead and at this point turn on display of RS chirality, just from the model menu, RS chirality. Okay, you'll see we're configured S. If you have R, if you did something differently, that's okay. I can show you how to change that in just a moment. Okay, let's go ahead and complete building limonene. Let's go back to the organic builder and just choose the sp3, the tetrahedral carbon in the upper left corner. And then choose the only valence available on the number 1 carbon. And then also just add on the vanillic carbon, just add over here. Okay, so this is limonene, and then let's go to the view mode. So if you have something else displayed, maybe you have the enantiomer displayed, let me show you how to address that. You can always invert the absolute stereo configuration. So you can always go from one enantiomer to another from the properties dialog, from the molecule properties dialog. So let's go to the display menu, properties. Typically this is, you drop into the molecules tab, and then actually the tab that I had open just a second ago, the utilities tab, is where you can change the absolute configuration. So if you build the R enantiomer, you can simply click this button. You'll get a warning message, hey, this is going to overwrite the calculations, and you have to say yes. But we can invert that. We can sort of invert absolute configuration. Okay, so that's one way of dealing with that. You can also deal with that within the build menu if you were in the edit build mode. What you can do while you're in the edit build mode is if you hold the control key down and if you double click on a stereo center, not on an open valence but on the stereo center, that will also invert the stereo center. Okay, so limonene. Okay, next I think we take a look at nicotine. So we'll get to use the rings builder. Okay, we'll go ahead and close limonene, and we'll take a look at nicotine. Okay, let's go ahead and take a look at nicotine as well. Let me put that over here. Okay, so we'll start out with benzene, and we'll do a substitution. This is pretty straightforward to build, but there is chirality in the system as well. So we'll take a look at that. Okay, so move this off to the side, and again we'll close out limonene, and let's build nicotine. So let's start out under the organic tab, and then let's go under the rings. If you don't have rings selected, click on the rings button, and then choose benzene, then double click on screen. And let's just pick any attachment point, and then let's go back to the rings menu and go and choose from the selection bar. Let's choose cyclopentane, so a 5-membered ring, and then just click to attach. And this will be phenylcyclopentane, and then we'll just build the pyridine moiety. We'll just do a substitution. So let's go over into the atom fragments, and let's choose the sp2 nitrogen, and then look at the attachment point of the 5-member ring to to benzene, and then just go 1, 2 over. So sort of the meta position, and then just double click. All right, so this is now, if the nitrogen is the 1 position, so this is 1, 2, 3 cyclopentylpyridine. Okay, and then what we'll do is we're going to make an additional substitution in the 5-member ring up here. So this sp3 carbon we're going to replace with an sp3 nitrogen, and it doesn't matter if you can either grab the pyramidal or the sort of planar option. Either one is fine, and then just double click to replace. And you see down at the bottom right, this is now, it says either R or S, or nicotine, and then we just need to, we'll wrap up by adding the final methyl group, and that's just down here. And this is nicotine. And let me go ahead and turn on display of chirality. So under the model menu, chirality, RS chirality, and this should be S. This carbon should be a S carbon, S-centered chiral center. I kept this in the build mode. If you go to the view mode, sort of clicking on the glasses icon, the hydrogens will automatically fill any of the open valences. But I just left it in the edit build mode just in case. If you built the other enantiomer and you need to invert it, that's easy enough to do. Just hold the control key down and then double click on that chiral center, and that will invert the center. Okay, from R to S. Okay, so nicotine has got this as an S center. Okay, so back to view mode, and let's move on to the remaining organic building examples. Okay, let's move on and build coumarin. The coumarin scaffold is actually, I think, part of a couple of anticoagulant drugs like warfarin, I think. Let me just go ahead and close nicotine, and we'll open we'll go to the new build, and I'll also, let me just one more time tap on the PDF file so we can see what coumarin looks like. It basically just a couple fused phenyl rings with a little substitution here with an oxygen substituted. Let me show you the easiest way to build this. Okay, so firstly we'll build a phenyl ring or just benzene. So just come over here to the organic builder and go to the rings menu and choose benzene. Double click on screen. Okay, and then let's go over to the organic builder and go to groups, and let's choose alkenyl. And then not the bottom, but just to the right of that, let's go ahead and click. And this gives it a good demonstration. I can either rotate the whole molecule around, sort of like this to orient things how I want. Or if we were back in this previous mode, what I could do is sort of rotate around this bond. You'll see that there's a red arrow that shows up from time to time on bonds as you're building. Essentially, you can click on any bond and the arrow will move around to that. That means that it's available for rotation. So over on the left-hand side, you see there's a little rotation strip. If you click in there with the left mouse and then just move up or down, that'll rotate around that bond. So basically just bringing the bond around to form a fused ring eventually. Okay, now let's go back to the groups menu, and then instead of alkynyl, let's go down and choose carboxylic acid. Carboxylic acid / ester. Maybe just to point out, you see the little yellow dot up here. This is the attachment point. So if we attach over here on the carbon, it'll be a carboxylic acid. If we attach over here on the oxygen, this will be an ester. So the default is over here on carbon, so make sure that's highlighted, and then just click over here at one of the terminal, one of the open valences on the terminal carbon. Okay, we'll do one more rotation. Okay, again, you see this little red arrow. I'm just going to rotate around and sort of move the OH over here, so it's sort of posed to make a bond here. Okay, and now the easiest way to do this is if you can see the open valences at the ends of the two atoms, you can just go into the build menu and go to make bond. It's also at the very bottom of the builders, at least the organic and inorganic builder, and then you can tap into the open valence and make a bond that way. That's easy. If for some reason, let me go back, let me do undo, or edit menu undo. If for some reason it's there's overlap or things are crowded and you can't get to the ends and jump on the end of an open valence, you can just do the following. If you just go to the build menu and then make bond, so build menu, make bond, and then just double tap on an atom to select it, and then double tap on the atom you want to make a bond to. That's also an easy way to do that. Okay, so we built the coumarin scaffold, and I'm just going to click the minimize icon at the top of the screen, also available at the bottom of the builders in the lower right. Okay, just to clean things up. Okay, so this is coumarin. We've gone through a number of organic building examples. I just want to point out a couple of things before we break. Okay, so let's use coumarin to demonstrate a couple of additional connections to data sources. Firstly, let's go to the view menu, and I'm going to move the molecule off to the left and go to the display menu properties. It's also a permanently displayed icon, and you can also get there by right-clicking on the background properties. Okay, and you'll see from the molecule properties dialog, one of the action items in the lower right is PubChem. And if you click on this, what Spartan will do is convert this drawing to an Enchi string and then do an Enchi string search of PubChem. So for example, coumarin. Okay, so here's one connection to a data source, and also a way to sort of confirm that you've built what you made what you think you've made. So let me close that. And then also, let me just point out the Spartan Spectra and Properties database. All along in the lower right corner, I've sort of mentioned you see a name. This just means that it exists in the Spartan Spectra and Properties database. And I have the option of doing a replacement, so I can just click Replace. That will replace the drawn structure with the calculated structure. So if I were to now go to the Properties dialog, I can go back to PubChem, but I now have calculated data available. So I've got highest occupied molecular orbital, lowest non-occupied molecular orbital, a host of calculated data available because this came from the SSPD. Okay, so that's a shortcut to the SSPD. And then I think I mentioned earlier that the coumarin scaffold is pretty common. I know it's in the drug warfarin, but it's fairly common as a substructure. So let's do a substructure search of the Spectra and Properties database. And the way we'll do that is we'll just go to the search menu and look at a structure query. And this drops us into a mode that sort of looks like we're building the previously, these hydrogens are now open valences again. And when you're in this search menu structure query mode, you can just click on an open valence to essentially open it up for searching. And I'll do the same thing here. So just at 2 locations, open this up and saying, so give me coumarin and anything with substitutions here. Okay, and now we'll go to the search menu, databases. Oh, it looks like I'd already done a direct search for coumarin. Now we're going to do this substructure search, and I'll click the search button. Ooh, and there's a bunch. So the SSPD is something on the order of 310,000, something like this, 309,000 molecules. And as far as coumarin is concerned, with these 2 positions open, there's 683 hits. Let me go to the top and just click on name to sort by name. This is roughly alphabetical. I think there's some weird things that happen with regard to capital letters and whatnot. But if I scroll a little bit, I'll see, here's warfarin. Okay. And you can see the substructure gets, here, let me see if I rotate it around. The substructure gets highlighted in the SSPD window. And by default, this is docked, but you can move the SSPD window out and change the size and do whatever you want. Okay, so those are 2 sort of data sources that are available that you can always utilize to confirm that you've done things properly. If it's in the SSPD, we have a small collection. I want to say that PubChem is something like 115 or more million compounds, so definitely use that as a resource as well. And then let me just point to 2 additional sort of common building questions. Okay, let's use coumarin as an example to demonstrate one of the last 2 items, which is just fused rings. There was another way we could have built coumarin. Let me just demonstrate that. If I go to the File menu, New Build, and let me go to the Rings menu under the Organic Builder, and let's choose benzene, double-click to insert. Let's go back to the selection bar and choose cyclohexane, and then double-click on one of these double bonds over here, so just double-click. That will fuse a cyclohexane ring here, and now we just need to do some modification of the ring. Let's go back to the atomic fragments in the Organic Builder, choose the sp3 oxygen, double-click on this sp3 carbon at the top. Let's go back and choose sp2 carbon, and double-click to replace this sp3 carbon, and then we'll add a doubly bonded an sp2 oxygen here to create the carbonyl group. And then we just need to make a double bond down here. Okay, so we can do that from the build menu, make bond, and then let's just attach 2 open valences. Okay, I'll minimize that. So here's another way we could have built coumarin. I don't know if it's any easier, but it does demonstrate the fuse rings. Let me take the fuse rings just a little bit further. If you go back to the rings and go, let's say to benzene again. Just essentially any available spot, any available single or double bond, you can double tap on to add an additional ring. And just keep in mind with regard to quantum mechanics that the QM calculations in the back end don't necessarily really care how you construct the system with respect to bonds. They really only care about the atom positions. Okay, so let's, now that we've seen fuse rings, let's do one final piece. A common question is, hey, how can I get a protonated amine, or essentially a tetrahedral amine? So let's go back to File menu, New Build. And the easiest way to do this is probably from the Inorganic Builder. So far we've spent our time in the Organic Builder. Just move one adjacent tab over, one to the right, and just click on Inorganic. Also has a selection bar at top, but in this case the selection bar is going to refer to the periodic table. So let's just go and select nitrogen. So N from the periodic table, nitrogen, and then you choose the valence type that you want. So we could choose planar, we could choose bent trigonal, or we could choose this tetrahedral, okay? And that's just a double click on screen. Okay, and this is probably the easiest way to get here. There are other ways to do so, but let me also just demonstrate one additional hook into the Spartan Spectrum properties database. I'll go back to the substructure search, and I'll just open these valences up and go to the database, and we'll do a search with search via structure. And there'll be some number. I don't know how many in the SSPD. There 300 or so thousand in here, so they're probably 100. I won't wait till this completes, but there's some small number of tetrahedral nitrogens in the SSPD, just to demonstrate that. The SSPD is primarily a charged or an uncharged and neutral system. Okay, so you can see them demonstrated here. Okay. All right, so some standard organic building examples, and then just an example of the access to the SSPD, also to PubChem, and then finally demonstration of fused rings and how to build a tetrahedral or a charged nitrogen. Okay? Very good, and now to the next tutorial, which is building in 2D, or rather sketching in 2D, and that's available under the Activities menu, Tutorials, and then sketching in 2D.